From the bizarre noises of energy particles to goals far beyond the solar system, today we look at what the Voyager spacecraft found in interstellar space. Number 12. The Voyager Program. NASA's goal for beginning the Voyager Interstellar Mission, or VIM, was to extend the exploration of the solar system to the boundary of the Sun's influence. Although the primary objective consisted of the planets within our solar system, the Voyager program wasn't limited to that. Traveling into interstellar space was always a possibility. VIM includes the Voyager 1 and Voyager 2, two robotic probes made to examine the far reaches of the solar system. Each spacecraft weighs 1,704 pounds and carries 231 pounds of scientific equipment. Voyagers 1 and 2 are identical, containing the same guidance systems, antennas, and photography capabilities. Number 11. Main objectives. Voyager 2 was launched on August 20th, 1977, and Voyager 1 followed 16 days later. These probes were designed using a lot of information gathered from the Pioneer 10, a spacecraft launched in 1972 that eventually reached the velocity required to leave the solar system, although it has yet to do so. Voyagers 1 and 2 were built with the primary mission of studying Saturn and Jupiter. Luckily for NASA, these probes went far beyond the two planets and have provided astounding information concerning the mysteries of deep space. Number 10. Jupiter, Voyagers 1 and 2. The first stop on the list for both spacecraft was Jupiter. Voyager 1 began its Jupiter flyby in January 1979 and became closest to the planet that March at 217,000 miles or 349,000 kilometers from the gas giant center. Voyager 1 was able to take high-resolution photographs of Jupiter. It maintained this distance for approximately 48 hours, taking some of the most detailed images of Jupiter ever seen. Voyager 1 also discovered that one of Jupiter's 4 Galilean moons, Io, experiences continuous volcanic activity, which has a significant impact on the planet's magnetosphere. Voyager 2 didn't get as close to Jupiter as its twin, only reaching 350,000 miles or 570,000 kilometers from the cloud tops. But the second probe confirmed the volcanic findings of Io. The Voyagers observed a total of 9 erupting volcanoes on the moon. Number 9. Saturn, Voyagers 1 and 2. Following Jupiter, the probes journeyed to Saturn, coming within 77,000 miles or 124,000 kilometers of the ringed planet's cloud tops. Voyager 1 found complex structures in Saturn's rings in addition to studying its atmosphere and Titan, the planet's giant moon. Both probes discovered that powerful winds blow near Saturn's equator, measuring 1,100 miles per hour. They also found phenomena similar to Earth's aurora borealis, or northern lights, in the form of ultraviolet hydrogen emissions near the middle of Saturn's atmosphere. With its flybys of Jupiter and Saturn, Voyager 1's primary mission ended, and its adventure to interstellar space began. Number 8. Uranus, Voyager 2. Voyager 2's mission wasn't complete after these two flybys, however. Following Saturn, the second probe reached its closest distance from Uranus in January 1986 at 50,600 miles, or 81,500 kilometers from the planet's cloud tops. Voyager 2 discovered 11 new moons and studied Uranus's singular atmosphere, the result of its 97.8-degree axial tilt. The spacecraft also found 2 new rings. Measurements suggested that Uranian rings are different from those of other planets and may not have formed until after the planet did. The photographs obtained of Miranda, the smallest Uranian moon, showed enormous canyons formed by geological faults, which some believe is the result of Miranda reforming after an impact that shattered it. Number 7. Neptune, Voyager 2. The last stop on Voyager 2's primary mission was Neptune. The probe was placed on a path coming within 3,000 miles or 4,950 kilometers above the planet's north pole. The route led Voyager 2 through a flyby of Triton, the largest of Neptune's moons. The probe discovered some new Neptunian rings, as well as 6 previously unknown moons. It also found a great dark spot on Neptune's surface, which is no longer there. Voyager 2 discovered liquid nitrogen geysers on Triton as well. When Pluto was classified as a dwarf planet in 2006, Voyager 2's 1986 Neptunian flyby officially became the instance that every planet in the solar system had been visited by a space probe. Number 6. 1992. V1974 Cygni. Following the main objectives of Voyager 2's mission, the probe observed Nova Cygni 1992, or V1974 Cygni, in the far ultraviolet. A nova is an astronomical event in which a bright star suddenly appears, causing incredibly intense light. The white dwarf star is located in the Cygnus constellation. It was the first nova to be observed from beginning to end, burning hydrogen for a total of 2 years. Calculations determined that V1974 Cygni is 10,430 light-years from Earth, each light-year equaling about 5.88 trillion miles. Number 5. Interstellar space. Voyager 1 reached the interstellar medium on August 25, 2012. The probe indirectly detected an electron density increase later on, leading scientists to believe the heliopause, a theoretical barrier where the solar wind of the sun is halted by the interstellar medium, had been crossed. Since these observations weren't set in stone, due to Voyager 1's failed plasma spectrometer, which stopped working in 1980, they weren't confirmed until September 2013. At that time, Voyager 1 officially became the first spacecraft to travel into interstellar space, which is 18 billion kilometers, or 11 billion miles, from Earth. Although Voyager 1 didn't cross over until 2012, it captured the family portrait of the solar system in February 1990. An image taken 6 billion kilometers, or about 3.7 billion miles, from Earth. Earth is pictured as a pale blue dot in the photograph, but the camera software has since been removed to conserve the probe's energy. Following its mission in the solar system, Voyager 2 began its interstellar mission. This space probe reached the heliosheath, the area in space surrounding and created by the Sun, in August 2007, and reached interstellar space more than 6 years after Voyager 1 on November 5, 2018. Luckily, Voyager 2's plasma spectrometer was still operating, providing the first straightforward readings of the temperature and density of interstellar plasma. Number 4. Heliosphere and heliopause. Many of the Voyager's discoveries are essential to the studies of the heliosphere and heliopause at the edge of the solar system. As we briefly mentioned, the heliosphere is a region of space contained within a bubble created by the Sun. The theoretical heliopause is where the solar wind isn't strong enough to repel the forces of the stellar winds generated from other stars. Many hypotheses concerning the plasma density within and outside of the heliosphere were correct. Mainly that plasma is denser and cooler in interstellar space than in the Sun's bubble. However, the heliopause isn't a rigid boundary like it's often depicted in illustrations. When Voyagers 1 and 2 crossed the barrier into interstellar space, scientists discovered that the heliopause leaks in both directions. Some interstellar particles go into the heliosphere, and some solar particles escape. According to the NASA website, the Voyagers also revealed that the heliopause can move as the Sun's activity changes, sort of like a lung expanding and contracting with breath, since each craft was a different distance from the Sun when crossing over. Number 3. Plasma waves. Although Voyager 1 couldn't provide direct measurements as it traveled into interstellar space, it did give scientists something incredible: audio of the interstellar plasma. This outer space music was captured from 2012 to 2013 as a result of solar activity, and was the first of its kind to be recorded. The eerie whistling of the plasma allowed scientists to determine when the Voyager 1 crossed over and gave the world a glimpse into space we'd never had before. Number 2. Golden records. Since the Voyagers are traveling through interstellar space and will eventually lose radio transmission capabilities, Carl Sagan, a well-known astronomer, astrophysicist, planetary scientist, and so much more, selected what would be placed on the golden records, which were situated aboard both Voyagers. The golden records contain a story of Earth through history meant for extraterrestrials that may discover them in the future. 8 blank copper records were cut and gold-plated before being placed in aluminum containers. Each record is 12 inches across and has a sample of uranium-238, an isotope with a 4.468 billion-year half-life, on its cover to provide a time reference. The records are inscribed with the words, "To the makers of music, all worlds, all times." The cover of each golden record is etched with directions on how to play the record correctly, the time of a single rotation, and time to play one side entirely, as well as the location of our solar system and a hydrogen atom in its 2 lowest states, to be used as the fundamental timescale, according to the NASA website. But what is on the records? Carl Sagan, along with his associates, placed 115 images on the records and various sounds of our world, including thunder, wind, waves, whales, birds, and other creatures. They also contain spoken greetings from the 6,000-year-old Akkadian language to the modern-day Wu and 90 minutes of music, ranging from Beethoven's Fifth Symphony to things like a Navajo Indian night chant. Number 1. The future. Although we'll never get to see the end of the Voyager's interstellar missions, the space probes aren't slowing down anytime soon. Along with their capability to tell Earth's story through the Golden Records, if they're ever picked up, Voyagers 1 and 2 are traveling through space at alarming rates, destined to arrive at numerous mysterious places in the hundreds of thousands of years to come. In approximately 300 years, Voyager 1 is theorized to reach the Oort cloud, a cloud surrounding the Sun beyond our solar system, theoretically made of small icy celestial bodies that some believe formed the planets. After the 30,000 years it takes for Voyager 1 to traverse the Oort cloud, it is expected to pass by the star Gliese 445, or the Camilo-Pardalis constellation, within a distance of 1.6 light-years. Voyager 2 is expected to pass by the star Ross 248 at a distance of 1.7 light-years. If the second probe remains undisturbed for 296,000 years, it is also supposed to pass by Sirius at a 4.3 light-year distance.